Hello class, in this video I'll be doing examples 4, 5, and 6 from section 8.1, inverse trigonometric functions, and we will be focusing on cosine. The first statement reads, if cosine theta is equal to y, then inverse cosine of y is equal to theta. And there is another way you can write inverse cosine of y. You can write it as arc cosine of y is equal to theta. So if you see arc cosine of y or inverse cosine of y, they mean exactly the same thing. The second statement reads, if inverse cosine of y is equal to theta, then cosine theta is equal to y. And this is the statement we will use to answer questions 4, 5, and 6. There are two restrictions. Y needs to be between -1 and 1 inclusive, and theta needs to be between 0 and pi inclusive. And that's because cosine theta is not necessarily a one-to-one function. However, if the domain is restricted to 0 to pi inclusive, cosine becomes a one-to-one function and will then have an inverse. So let's take a look at example number 4. It says determine the exact value of inverse cosine of 1/2. So I'm going to start by writing out a sentence. If inverse cosine of 1/2 is equal to theta, then cosine of theta is equal to 1/2. And if you look at the unit circle, there are two angles that satisfy this equation. That would be theta is equal to pi thirds and theta is equal to 5 pi thirds. However, only one of these angles lies in the interval 0 to pi, and that will be pi thirds. 5 pi thirds is too large. So it's not in the interval (0 to pi inclusive). So what we're going to do is we're going to ignore theta is equal to 5 pi thirds, and the solution is the inverse cosine of 1/2 is equal to pi thirds. Example 5. Determine the exact value of the inverse cosine of -square root of 2 divided by 2. And I'm going to start this problem exactly the same way I started example 4. So if the inverse cosine of -square root of 2 divided by 2 is equal to theta, then the cosine of theta has to equal -square root of 2 divided by 2. And on the unit circle, you'll find the two angles to be 3 pi fourths and 5 pi fourths. However, only one of those angles is in the interval 0 to pi, and that angle is 3 pi fourths. Just like the previous example, 5 pi fourths is too large and is therefore not in the interval 0 to pi. So the answer to this problem is cosine inverse of -square root of 2 divided by 2 is equal to 3 pi fourths. Example 6. Determine the exact value of the inverse cosine of 5 fourths. So once again, I'm going to write out a sentence. If inverse cosine of 5/4 is equal to theta, then cosine of theta is equal to 5/4. And you can search, and you can search, and you can search, but you will never find an angle whose cosine value is 5/4 because that number is larger than 1. So in this case, the inverse cosine of 5/4 has no real solution.